In this problem, we've got x cubed again, and we want to find the area between x cubed, the x-axis, and the lines x is equal to minus 2 and 2. So our areas in this part here and in this part here that we want to find. Now, I'm going to go back and see that, well, I know x cubed is an odd function. My area in this part is the same as my area in this part. So if I did minus 2 to 2 of x cubed, I know that's going to end up as 0. My definite integral would be 0. So to find the area, I can either split it up and go from negative 2 to 0 and take the absolute value, or I would prefer to go two lots of 0 to 2 of x cubed. I know this area is the same as that, so I'll find the area here and just double it. And that's what I've done. X cubed becomes x power 4 on 4. We're going between 0 and 2, so substitute 2 in, substitute 0 in, double my answer, I get 8. So this area is 4, this area together must be 8 because it's exactly the same. We're talking area, so we're not talking any direction, we're just talking magnitude. So in question 5, so we've got the area bounded by x squared minus plus 2x, the x-axis, and the lines minus 1 to 2. So there's minus 1 and 2. Again, we factorise x and x plus 2 to see that x when it's equal to 0, x is equal to 0, and x is equal to minus 2. So there's how we get our parabola. Now, if we look at the area we require here, we've got that little part there and the rest of the areas in that part. So we need to say this is going to give us a negative. So between negative 1 and 0, let's take the absolute value. So that's why we've got that part there. So absolute value of that. And we follow it right through. Negative 1 to 0. Absolutely integrate it. Substitute. And we can see that, yeah, it would have given us a negative. So we're going to get a positive. The rest we're just going 0 to 2 of x squared plus 2. So we've done that right through. And we get 7 and 1/3 units squared as our answer. So again, we've got to be really careful. The part here is going to be negative. So we're going to have to take the positive value. We're going to have to take the positive of it, just taking its size, not its direction. This one, again, it's nice and nicely factorised. We can see that it's going to, when that y is equal to 0, x is 0 or 1. That's our concave down. So we can see our areas in this part. So when we look at that now, we're going to take the area between 0 and 1 of the function. It's not too bad because it's above the x-axis, so we didn't have to take any negatives. That it was important to see where our limits of integration come from. So that's where we had to do a bit of work before we actually started. We weren't told the limits of integration. We just had to calculate them ourselves. So be wary about having to factorise correctly. Question 7. This one again, I'm looking at 4 minus x squared and the area there. So again, I know my values are going to be minus 2 and 2 when I factorise this function. I can get my values where it goes to the x-axis. I'm going all the area here. Again, I'm going to just look at this and go, well, wait on. This is my axis of symmetry of my parabola, which means it's an even function, and these two areas are exactly the same. So I think I'm going to go to the idea that I'm going to integrate between 0 and 2, find this area, and double it. So, and that's what I've done. Again, I could have done negative 2 to 2. That's not going to be any problem because they're both above the x-axis. So it's not a case like the odd function where it's going to give me an answer of 0. I will be able to get a nice answer without having to worry about absolute values. But again, I like substituting in x is equal to 0 for the x values here, which makes life a little bit easier in my calculations. So, and then just doubling it. So integrate the function as we've done, substitute the values in, and then double our answer at the end. So again, if you can use that way, sometimes it just works out a little bit easier. I think that the calculations aren't as hard. This time, again, we've got 7 plus 2x minus x squared. So we want to make sure where we got our values. So if you can see, like, there's a little bit difficult here because these ones are not going to be nice values. So if you have a look, and you can actually get the areas, you can get the limits of integration, sorry, the roots of that. Probably have to do the quadratic formula. So you can see where it actually exists. So it's out here. It's not going to affect the idea that we've got the negative 1 to 1, so which is our limits of integration, because that's the curves, the two lines, the curves is taking the area between. So that's not going to affect it. But again, unless you draw it up correctly, you're not going to realise that. So you've got to be really careful to make sure you've got a reasonably decent diagram. So we can see our areas above the x-axis. That's not a problem. So we can integrate it with confidence between -1 and 1, substitute our values in, and be able to get an answer that we know that we're confident with, because it's all above the x-axis. So there's nothing that's below the x-axis that we're finding there.